Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in MBSS 222 of the Math and Behavioral Social Science building. It is my job to help students through their math courses here at Walter State, and I do so in various ways by tutoring personally and by doing these podcasts. And today's podcast is about how to graph lines. And so what we're doing is graphing lines from equations, how to graph a linear equation given a line. And we're going to start with some lines, and I'm going to show you how to graph them, and hopefully this will help. If this is not enough information, remember you can always stop by and see us in room 222, and we'll give you some additional help. The first equation I have is y equals 2x minus 1. And I want you to remember that as we do this, again, and I've said this for every podcast, these podcasts are not designed to replace lectures, but to explain how to do specific problems and to supplement your classroom lectures. And I assume that you have had y equals mx plus b in your class, and that you know all about the slope and the b, or your y-intercept. And our y-intercept in this case is the number by itself, and the slope is always the number in front of the x. So our slope in our problem is 2, and since slope in a graphical or visual representation is rise over run, we want to write our slope in fraction form. Whole numbers, like we have here, can be written over 1. Our y-intercept is -1. We want to include the sign with it, so our y-intercept is -1. Now, we have two pieces of information, and we want to use those two pieces of information to connect and to make the two pieces of information together to form a line. Which one do we start with? Well, we want to start, if you're going to make a fence, where do you start? You start with a corner post. Well, our corner post is the y-intercept. Where does it touch this y-axis? It touches this y-axis at the y-intercept. That y-intercept is -1. If we let x be 0, then the y is equal to -1. If that x disappears, notice how I'm covering it up. If that x disappears, then that y equals -1. So we've got the point 0, -1. 0, -1. Now, the next thing we want to do is, and I'm going to keep my finger here, notice that as I graph, that I use both hands. You'll see both of my hands on the screen as I do this. It is a two-handed job. Okay, I use my left hand to hold my place. I see students do all their homework and their left hand is just over to the side not doing anything. I make this hand do stuff because it keeps me thinking. So put your left hand on this point so you don't forget. This is our corner post of our fence. Our line is our fence. This is where we're running from. We're going to rise and run from this place. We're going to rise 2 and run 1. Now, technically, we can do in any order that we want. We're going to stay consistent by doing it all the same way every time. So we're always going to do the top first, then the bottom. How are we going to remember what to do? Well, if you think about it, you have to rise up or stand up before you can run. So we're always going to move the y value before we move the x value. Because remember, too, that our slope, and I'm going to come down here and write that down here, our slope is rise over run, but it is also the rise is the change in our vertical distance, y2 minus y1, over x2 minus x1. It's how the y's change. So we're going to go up 2. For every 2 units in the y direction, we go 1 unit in the x direction. For every 2 units in the y direction, we go 1 unit here. Now, let me do that again. Where did I start? Notice I started where my finger was pointing. I left my finger on the starting corner post. That corner post was at -1. Then I went up 2 for my rise over 1. Up 2 over 1. I can count that ratio until I run into my words up here. And if I wanted to, since I now have that pattern, I can figure out how to drive in reverse. And we just want to follow that pattern to figure out how it drives in reverse. Now, if you can't figure out how to drive in reverse or how to build your fence in reverse, don't worry. You just need to go in one direction. So you can just use the points that we have to start out with, here, here, and here. Now, I'm going to connect those points. Just take a straight edge and connect your points. And you've drawn your line. That's all there is to drawing your line. Now, we want to check this. Now, some of you will be having a gateway where you'll have to do this without a calculator. And when you do it without a calculator, you won't be able to check. Well, right now, I'm not using a gateway. I'm wanting to learn, and I want to be able to check my answers. So I'm going to come into the calculator. I'm going to press y equals. I'm going to clear out anything that's there. I'm going to type in my equation, which was 2x minus 1, and I'm going to hit graph. And I've got it set to a standard window. If yours is not at a standard window, zoom and then number 6 for standard. And hey, it looks pretty much like what I've got drawn here, but so would a lot of other things. So what really is going to help us check is to be able to graph some specific points. And I'm just going to choose a point at random. I'm going to choose the point 2, 2. Slide that there, and I'm going to come over here and graph I can't read. The point 2, 3. I learned to read. So I'm going to go over 2, up 3, and that's a point on my graph. How about -1, -3? -1, -3. There it is on my graph. And so I've got a couple of points that are on my graph, and so my graph is accurate. Okay, let's look at another example. Don't ask what that was. Trying to decide where to write my information. Okay, let's look at this one right here. We have y equals 2x plus 3. Again, my slope in this case is the number in front of the x. It's 2/3. It's already, in this case, in fraction form, so that it already gives me rise over run. Notice that I write down that it's rise over run. It's just easier and makes things in life easy if I go on and do that. Then my b is the 3, and that tells me my y-intercept. Take the y-axis, come down to 3, draw a point, move my left hand, and hold it there. That's my starting point. I do not want to start back over from the origin. I want to start from where my finger is pointing. And then I'm going to do what? I'm going to go up 2 over 3. So with my finger here, notice by holding it there, I remember where to start. I don't go back here, I go to my finger. Then with here, I go up 2 units over 1, 2, 3. Up 2 over 3. Now, notice this time I wrote the numbers in so you could see that. up 2 over 3 because it was a little bit more complicated, but you're not going to write those in. That's what you're thinking. And because I can't be there with you to hold your hand as you're doing it, because of the limitations of a podcast, I'm going to actually write those. But you don't write those, you just think those. Then with your pencil here, and again, notice I moved my finger, I'm going to go up 2, out 3. Notice I'm out a graph. So I'm going to stop, and this time the pattern's a little difficult, so instead of finding the pattern, I'm just going to line up my 3 points and draw my line. Well, if it's 3, 2, 2, 3, think about going them backwards would be 3, 2. 3, 1, 2, 3, 2. Well, that's close. 3, 2, that's close. 3, 2, that's a little bit further off. You're only as accurate as your pencil is thin or thick, and we've got some points there. Go back to your y equals. Remember what our equation was? It was clear, parentheses 2 divided by 3x plus 3, second table. And we're not going to go any of these fraction points. We know the 0, 3 was right because that was our y-intercept. 0, 3. 3, 5. Let's see if the point 3, 5 is on my graph. 1, 2, 3, 1, 2, 3, 4, 5. There's the point on my graph. The next whole number I get is the point 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It's on my graph. So I've got an accurate graph. And I checked it. Okay, next let's look at y equals x. Probably the hardest graph to graph, or the easiest graph to graph, depending on which way you look at it. Now, why is it the hardest graph to graph? Because people look at it and say, there's no information, there's no numbers, there's just letters. It should be the easiest graph to graph because all the numbers are ones and zeros. And ones and zeros ought to be easy numbers, but we don't see the ones and the zeros. We see variables. We don't see the understood. And I think the understood numbers are the hardest for students to gather and understand. When we have y, then we have an understood 1x. Anytime we have a variable by itself, it's always understood to be a 1. Technically, we have a 1y here. But 1 times y is just y. But we need a number in front of the x so we can have slope. So it's understood to be a 1. Then we need a number out here to be our y-intercept. And since there's not a number, it's understood to be 0. Well, why not in reverse? Why not 0 here and a 1 here? Well, if I put 0 in front of the x, 0 times any number is 0. It would make the x disappear. 1 times x gives me x back. So that has to be 1 when we're multiplying. If we add anything other than 0, we change the value. So we want something out here that doesn't change the value. What doesn't change the value? Adding 0. So now I've got it in a form where I can determine that my slope is 1 and my y-intercept is 0. Because my slope needs to be in fraction form, I'm going to put it over 1 over 1. And look what I did. I didn't leave myself room. And you want to do it until you have gotten really good at graphing. Rise over run. My y-intercept, where does it cross the y-axis? At 0, 0. This time we are going to start at the origin, but again, I put my finger there to hold the place, and then my slope is up 1 over 1. Up 1 unit, over 1 unit. Up 1 unit, over 1 unit. Which if we go backwards, it's working in reverse. That gives us additional points. sure that looked really good on videotape. And we'll draw the points together and we have our line. Notice that I usually extend my lines all the way across my paper till I'm off of my graph. I don't just stop at my points, and lines should have arrows at the end to indicate that they keep going and going and going. They're like little Energizer bunnies. They never stop. Okay, let's look at the next one. We have y equals negative x minus 4. Our slope, remember, if it's not got a number in front of it, it's got a 1. And so in this case, our slope is a negative 1. It's a whole number. We need to write it over 1. And then that gives us rise over run. And then our y-intercept is negative 4. So we're going to go down 4. And then our slope is down 1 over 1, down 1 over 1, down 1 over 1. And look what I did. I run right into our little words. But I'm also got a very short, down 1 over 1. So I probably want to kind of reverse those movements, down 1 over 1, over 1, up 1, over 1, up 1, and just kind of work in reverse motions. And I really think of it as just kind of going in reverse. If not, you just line up the ones that you did forward and you draw your line. You do not have to go in reverse. Some of you will get this and understand how to move in reverse with no problem. Others of you will have difficulty with it. But what I do want you to understand as we do this is how to look at y equals negative x minus 4 and understand that that's negative 1x minus 4, so that your slope is negative 1, that the slope is written over 1, and you get rise over run. Our y-intercept's negative 4, so we go down 4. This is where we'll start. Then we'll go down 1 over 1, down 1 over 1, down 1 over 1. We've gotten 4 points, and that's more than enough to put your straight edge and draw your line. Okay, now all of those lines were solved for y. Not all of our lines will be solved for y. Some of our lines will be given to us in other forms, such as 3x minus 2y equals 12. And there are two methods that I'm going to talk about as we look at this one to graph. One is what I call the cover-up method, and I borrowed this from Miss Medford, and I think Miss Martin may do it too. But originally Miss Medford was the one that used this, and I love the way she taught it, so I've always borrowed it and used her method. And the other method is to solve for y. So I'm going to use the cover-up method. And for the cover-up method, basically what I'm doing is I'm finding the x and the y-intercepts. And I'm finding and letting x be 0. If I let x be 0, I get 3 times 0 minus 2y equals 12. Excuse me. And this 3 times 0 is 0. 0 minus 2y just gives me negative 2y equals 12. Well, I can see that really easy if I just cover up the x. Do you see that that's what I've written down here? That's why she calls it the cover-up method. You cover up the x value. So you get negative 2y equals 12. Cover it up, write that down, and you do not have to write that step down. And for students that are very good with their signs, you don't even have to write the next step down. 12 divided by negative 2 is negative 6. And if you can do all of that in your head, you can do it. If you're struggling, you want to write down not this step, but this line, and this line. And we divide it and we get y is negative 6. And so what we did is let x be 0. We put 0 there and we got negative 6. Now we're going to do the same thing letting y be 0. 3x minus 2 times 0 equals 12. Well, again, 2 times 0 is 0. 0 from anything is just that. So we get 3x equals 12. If I put my finger over this, what do I have? I have 3x equals 12. 12 divided by 3 is 4. And since that's an x value, we put it here. So the first thing I do is draw a little table with the 0 for an x, a second point with the 0 for the y. When x is 0, I cover that up. You take this number, divide by that number. 12 divided by negative 2. Negative 2y equals 12. Divide by the number in front of the variable. That gives you your y value. Write your y value there. Cover up. When y is 0, the y goes away. You're left with 3x equals 12. Again, we're not going to bother writing that step ever again. 3x equals 12, divide both sides by 3, x equals 4, and I have 2 points. And 2 points are enough to write the equation of a line. So I have 0, negative 6, and the point 4, 0. 4, 0. And I've graphed those 2 points. And I can connect those 2 points to make my line. It is a quick way to graph equations. And I love this method of graphing equations. Now, the other way is to solve this for y. To solve 3x minus 2y equals 12 for y, we're going to move 3x to the other side of the equation. When we move it across the equation, we're really subtracting 3x from both sides. Now this we're not going to show, we're just thinking that that's what we're doing. So it comes across the equation and it becomes negative 3x plus 12. Then we divide by negative 2, and y equals positive 3/2 x, because a negative divided by a negative is a positive. 12 divided by negative 2 is a negative 6, and we get 3/2 x minus 6. Now to graph that, my y-intercept is negative 6, and my slope is 3 over 2. Up 3 over 2. Up 3 over 2. Notice I'm hitting those exact same points. So I get the same answer either way. Stepping away from the mic. There to cough. Excuse me. Okay, now let's look at one last example, and we'll call graphing done. And we're going to look at 5x minus 3y equals 15, and we'll do it both ways as well. And we're going to do it quick and dirty. Remember the cover-up method. Cover up the y value. We're left with 5x equals 15. Divide by 5. Divide by 5. X equals 3. Uh-oh, I did this one in the wrong order. But that's an x value, so I know it goes in the x column. Cover up the x value. I've left with negative 3y equals 15. Divide by negative 3. Oops, you can't see that. Divide by negative 3. Y equals negative 5. 0, negative 5. 3, 0. And there's the 2 points, and I've got it graphed. I love this method. It is a quick and easy method when they're already in this form. It does not work if it's not in the form like this. If it's already solved for y, the other way is much quicker. Now, let's take a minute to solve this one for y, because sometimes we do have to do that for other reasons. The 5x is going to come to the other side, so we're going to get negative 3y. Remember, when it crosses over, it changes signs. Then we're going to divide by negative 3. Negative divided by negative is a positive. Minus 5, so we get y equals 5/3 x minus 5. There's my y-intercept. From there, I've got to do up 5, 1, 2, 3, 4, 5, run 3, 1, 2, 3, up 1, 2, 3, 4, 5, run 1, 2, 3. And again, my pencil's a little bit on the thick side, or my ruler's a little bit off, so I'm a little bit off, but I'm as accurate as you're going to get with the pencil. I hope this helps teach you how to graph. If you need some additional help, be sure you come and see me in MBSS 222, and we'll be glad to give you that help. Thank you.